Okay, we talked about using the K expressions to solve for different equilibrium conditions. A simpler and more obvious comparison that tells us how far a reaction has gone or if it's a complete reaction or not is the percent reaction. Percent reaction is given by the concentration of a product that is at equilibrium in comparison to the concentration of that same product that would exist if the reaction had gone to completion. So, if the reaction goes to completion here, these two numbers are the same and we get 100% reaction. If 50% of it reacts as expected, that's a perfect example of when we consider to be something in an equilibrium. And if we get like less than 1% formed of what we expected to form, we might consider that to be no reaction. Or obviously very, very little reaction. So let's look at some equilibrium situation here, and let's compare the K value to the percent reaction and see if we can sort of understand how the two things works together. We have nitrogen gas reacting with hydrogen gas to form ammonia. Here, if this guy decreases by a factor of x, this guy is going to decrease by a factor of 3x because 1 to 3 ratio in their moles, and we're going to produce 2x of this. Since we start with 0 of this, we know the reaction is going to tend in this direction because it has to produce something of that. Now here I started at 0.15 and I took away x and I ended at 0.01, so I can figure out that x must have been 0.14. If that's 0.14, then 3x must have been 0.42. So if I take my 0.42, so if I take 0.5 minus my 0.42, I can see that I'm left with 0.08 molarity of H2. And finally, 2x would be 0.28, and I started with nothing and have created 0.28, so that's how much of that I'm going to get. Now, if this reaction had gone to completion, it would have used up all of this, and it would have produced as much of this as it could. This is an excess if you look at this carefully. So what that means then is that a complete reaction would have had x at 0.15. This is the complete reaction. And as a result, 2x would have been 0.3. So our percent reaction compares our concentration at equilibrium, 0.28, to our concentration for a perfectly complete reaction at 0.3. And here I'm going to get a percent reaction of 93.3%. This means that the products are heavily favored. And most of our reactants have become products. This reaction is incomplete, but it's close. What does that look like for a K expression? Well, the K expression has our products over our reactants, so we have our ammonia divided by our reactants. And we have to be careful here. This is molarity and this is molarity, so there's no units here. But we have to be careful here because there are going to be units and they're not going to cancel out, so we need to watch what they are. I have 0.28 moles per liter on the top, squared. I'm left with 0.01 moles per liter of the ammonia and 0.08 moles per liter of the hydrogen. So 0.28 squared divided by 0.01 divided by 0.08 cubed. And I get 15,312.5. So obviously a very, very big value. Notice I had molarity squared on top, molarity to the fourth on the bottom. So this is 15,312.5, molarity to the -2. So that's our units here. And here, a large K is also indicative of the fact that the products are heavily favored. So a percent reaction, the closer it is to 100, the more products you're getting, or the closer it is to a complete reaction. With a K expression, the larger K, the more the products are favored and the closer it is to a complete reaction. Either way, those are two ways to quantify how much of a reaction happened.